We'll now look at solving exponentials where we can't do the property of writing things with the same base. So instead, let's look at something like 12 to the x equal to 13. We can try to solve this, but we can't write 12 or 13 in the same base, so we're going to need other methods. And essentially the method is to take the natural log of both sides. And this is going to be the method anytime we can't write the base is the same. So I'll have ln of 12x equal to ln of 13. And then from there we're going to have to use our properties of exponents that say we take this exponent and move it out front. So x ln 12 equal to ln 13. Now, ln 12 and ln 13 are just numbers, so we can divide both sides. And now I just have that x is ln of 13 over ln of 12. And this is a number, and it does give us our answer. It may not be the best answer, but it is an answer. Ultimately, we can use a log of whatever base that we want. In our first step, when I took the natural log of both sides, I could have taken log base 10 of both sides. I could have taken log base 12 of both sides. Usually we stick to ln because calculators can evaluate the natural log, and so this is something that I could just stick into a calculator and actually get an estimated value. So we tend to stick to taking the natural log of both sides. Another one, 16 to the x power equal to 67. Once again, we'll take the natural log of both sides and get ln of 16x equal to ln of 67. We can use the property that lets us move the exponents out front. So now I have x ln 16 equal to ln of 67. And then, since ln of 16 is just a number, we can divide both sides. I now get ln of 67 over ln of 16. So now let's look at a slightly more complicated example. 11 to the x minus 8 minus 5 equal to 54. This one actually has one step ahead of what we've been doing. When we take the log of both sides, I actually need the exponential by itself. So my first step here is going to be to add 5 to both sides. 54 plus 5 is 59. And now I can use what I've been doing. I have ln of 11 to the x minus 8 equal to ln of 59. And now I can bring my exponent out front. The key though is this x minus 8 has to stay in parentheses. I have to multiply that entire thing by ln of 11. I can now distribute x ln 11 minus 8 ln 11 equal to ln of 59. So we have a slightly more complicated equation, but it's still not too bad. We try to isolate the x, so we'll add 8 ln 11 to both sides. So now on the right-hand side, I have 8 ln 11 plus ln of 59. Now when I divide, I have on the right 8 ln 11 plus ln of 59, all divided by ln of 11. So I have my answer. So whenever we have something in the exponent that's not just a single variable, make sure you do distribute your natural log, and then we can solve just like we usually would. As another example, e to the x minus 1 minus 5 equal to 5. We start by adding 5 to both sides. 5 plus 5 is 10. We then take the natural log of both sides, and we can move the exponent out front, and once again make sure it's actually in parentheses. This time, instead of distributing, we're going to just simplify. ln of e, well, this means e to what power is e? Well, that's just 1. So ln of e is just 1. So the left-hand side is just x minus 1. So then when I want to solve for x, all I have to do is add 1 to both sides. And we have our answer.